So these examples here, we're going to factor difference of squares and perfect square trinomials. So with this first one here, we know that this is a difference of squares because the first term and the last term are perfect squares, and there's a subtraction sign in the middle. So they're really easy to factor. All you do is you take the square root of the first term, which is 15a, and the square root of the last term, which is b, and you put them each in their own set of brackets. And you give one a plus sign and one a minus sign, and then we're done. Okay, b looks like it's set up to be a difference of squares because there's two terms and a subtraction sign, but we notice that 7 is not a perfect square, but they each have a 7, so let's factor it out. Then we're left with x squared minus y squared. And now x squared and y squared are perfect squares. So leave the 7 out, open some brackets. So square root of x squared is x, square root of y squared is y, and we put one plus and one minus sign, and order doesn't matter for plus minus, it could be the other way too. Okay, C, 25x squared y squared is a perfect square, as well as 1, and we have that subtraction sign, so we're good to factor. So square root of the first term is 5xy. So we'll put it in each, 5xy. And square root of 1 is 1, and we put 1 plus and 1 minus. Okay, D, the first term is a perfect square. The last term is also a perfect square, but because it has this plus sign, it's not a difference of squares. So if it has a plus, this can't be factored. So we just leave it the way it is. So difference of squares has to have a subtraction sign. Okay, so next up, these are trinomials. So the way you check to see if they're a perfect square trinomial is you take the square root of the first term. For this one, it would be x. The square root of the last term, so square root of 4 is 2. And then the middle term has to be 2 times the first and last term multiplied. So x times 2 is 2x. So we check, is my middle term 2 times 2x? Well, yeah, because 2 times 2x is 4x. So yes, this is a perfect square trinomial. So then to factor it, we take the square root of the first term, which is x, square root of the last term, which is 2, and whatever this first sign is, that goes in the middle, and then we just square it. Okay, so F here, a trinomial, we notice that the first term and the last term are both perfect squares, so we'll just check if it meets the criteria. So square root of the first term is 5x, square root of the last term is 9, and now our middle term is supposed to be 2 times these two multiplied. So 5x times 9 is 45x, and 2 times 45x is 90x, so we're good. So to factor it, square root of the first term is 5x, square root of the last term is 9, and we notice it's a subtraction sign, so that goes here, and then we just square it. Okay, G now. So last term is a perfect square. Sorry, first term is a perfect square. Last term is a perfect square, so we'll just check the middle. So square root of the first term is 1. Square root of the last is 8x. And to check the middle, it should be 2 times 1 times 8x is 8x. And 2 times 8x is 16, so yes, a perfect square. So square root of the first term is 1, the last term is 8x, and our sign is a minus, and then we square it. Okay, last one. So first term is a perfect square, it's x. Last term, 50, isn't a perfect square, so that means this is not a perfect square trinomial, not a perfect square trinomial. So then we see if it can be factored using inspection. So that, remember, is we need two numbers that multiply to give me 50 and add to give me negative 25. And there turns out to be no factors of 50 that will give us 25. So this whole trinomial, it can't be factored. So we just kind of leave it the way it is. So those are examples of difference of squares and perfect square trinomials.